All right, so here's number 13 from paper 1, 2014. Okay, a liquid is heated so that after 20 seconds of heating, its temperature T is 25 degrees Celsius, and after 50 seconds, it's 37 degrees Celsius. So, temperature of the liquid at time T can be modeled by capital T for temperature equals A times T for time plus B, where T is the time in seconds after the start of heating. Okay, using this model, one equation that can be formed is 20A plus B equals 25. So that's from these two numbers here, right? Oh, oops, that's not right. Look, it's these two numbers here, right? Here's our 20 seconds and our 25 degrees Celsius. And then they want us, using the model, write down a second equation in A and B. So we're going to want to use the 50 seconds when that turns out to be 37 degrees Celsius. So we'll just copy this one right here. So instead of 20 seconds, it's now 50 seconds. So 50A plus B should equal 37, right? So that's this one right here. Okay. Using your graphic display calculator or otherwise, I would suggest otherwise, find the value of A and B. So look, now we've got a system of equations right here, right? So what we're going to want to do is, the easiest way it looks like is to try to eliminate the B. So I'm going to multiply this line up here by -1 to turn that positive B into negative B. So when we add them together, they'll eliminate the B's. So I'm going to bring this down here so we have some room to work. So we got negative 20A plus B. Oops, not plus B, now it's negative B. That's the whole point of doing that. So minus B equals negative 25, and now we're going to add that to the other line, which is 50A plus B equals 37, right? So now when we add these together, those will, the B's will disappear. We get 20A minus 50A gives us 30A, and then over here 37 minus 25 equals 12, right? So to find A, divide by 30, and we get A equals 12/30ths, which is, let's see, divide both those by 6, and that's 2/5, which is 0.4. I'm going to go with that. Okay, so A is 0.4. And now that we know what A is, we can figure out B by plugging A into either one of these equations, or we really could plug into that one if we wanted to, but I think this first one here is going to be easiest, so let's do that. Let's do that over here. So we've got 20 times A, which we now know is 0.4, plus B is going to give us 25, right? So 20 times 0.04 is 8, plus B is 25, so subtract 8, and we get that B equals, what, 17? All right, so there's our two values. A is 0.4, B is 17. Okay, using, okay, that's what we just found. So we did A, we did B. Use the model to predict the temperature of the liquid 60 seconds after the start of heating. Okay, so look, this is way back up here where they gave us our original formula. We know the temperature now is A, which is 0.4, times T, plus B, which is 17. So hopefully you're recognizing this as a linear model here, right? So for T every, what is this, second, it's going up by 0.4 degrees Celsius, and our starting temperature should be, according to this model, would be at 17 when time was 0, right? So use the model to predict the temperature of the liquid 60 seconds after the start. So let's use this down here. So the temperature is going to equal 0.4 times 60 plus 17. All right, so again, we got our calculator. Let's just use it. Let's see, we're going to go 0.4 times 60, add 17 to that, and 41 degrees it is. So T equals 41 degrees Celsius, I would go with. I want to be as specific and thorough as you can. All right, that's number 13.